Okay, this is a great electric circuits question. Go ahead and pause the video and give this question a read before we go through the solution. All right, so the first thing I'm going to do is convert that to amps because milliamps is not something we want to use. We're really only given two additional pieces of information in the text here. We are given the voltage drop across the resistor, and we know the current running through this ammeter. Important to note, we don't know the total current, but we know, for example, the current passing through here. This question is asking for the resistance of resistor R. Now, the only thing we're missing to solve this by Ohm's law, since I know the voltage drop is 1 volt, the only thing we're missing is the current through R, and then I would know the resistance of R. So you sort of have to work backwards and think, okay, I need to figure out this current on this pathway. Now, the direction of current in this problem is irrelevant. If you flipped it around backwards, it wouldn't really matter. I think it's easier to kind of imagine it coming this way, where the junction is here. So to find the current through R, I would need to know the total current, because if I simply don't have enough information here to figure out the current there. But if I could figure out the total current, hopefully you know the junction rule. If you do not, you should review that. But the current is going to split here. So if I could find the total current here, for example, the current passing through here, I would be able to figure out when it splits the remaining current passing through resistor R. So how would I figure out the current through one of these 20 ohm resistors? I say one of these 20 ohm resistors because they're both in a location of the circuit where they would have the total current passing through them. There's no branching at this point or in this section of the circuit. It's just over here really where there's branching and it gets more complicated. So I need the current through, let's say, this resistor. If I go back to Ohm's law again, let's say the current through this 20 ohm resistor, you can see that you're kind of in another spot where you don't have all the necessary values. I know the resistance is 20, but I don't know the voltage across this resistor. You can figure it out pretty quickly though. If you figured out that this voltage drop was also 1 volt, you are correct. How do we know that? If we know that this has the same current as this, if it's the same resistance and the same current, then these two guys here, these 20 ohm resistors, would have to account for the remaining voltage drop. Picture this pathway. The sum of the voltage drops should equal the voltage of the battery. If I lose a volt here, this 1 volt drop, then it kind of means that these will equally split the remaining 2 volts. That is a bit of a tricky side tangent that really makes this problem quite tricky. But if you recognize that, then you get to the point where you're here and you know that it's 1 volt and 20 ohms. So that is for this, the current here, anywhere along that red. The total current is 0.05 amps. Now the rest of the problem is pretty straightforward. If it's 0.02 amps going through here, then hopefully you're already picking this up, that the remaining current through R would be 0.03 amps. Just because of that split or that junction, I'm going to erase some of this because it's hectic. With 0.02 going through here, we would have 0.03 going through there. Now that I know, back to my starting point, I have figured this out and I can solve this pretty quickly. The resistance of resistor R would be equal to that 1 volt potential difference across it, and it has 0.03 amps of current running through it, which gives you most nearly 33 ohms.